Hello and welcome to an introduction to weight statistics in SQL Server 2019. My name is Mike West and I'll be your instructor for this course. This course is a high-level applied look at using weight statistics in the real world to solve your SQL Server problems. Now this isn't a deep dive, but I'm going to provide you with some critical information you need to know how to troubleshoot real-world SQL Server problems. I'm going to show you how to get the most out of using weight statistics in the shortest amount of time. You'll discover what weight statistics are and, more importantly, how to use them to troubleshoot SQL Server outages and performance issues. This course will be very little theory. The focus will be on how to solve problems in the real world using weight statistics. SQL Server spends a lot of its time weighting. It catalogs these weights and provides you with critical insights into why and what the SQL Server is waiting on. The basis of performance tuning in SQL Server using weight statistics is simply that we interrogate these statistics to find out the primary reasons why requests are being forced to wait, and then focused on tuning the efforts to relieve these bottlenecks. Thanks for your interest in this course, and let's get started learning about weight statistics in the real world. All right, hello and welcome back. In this brief lecture, let's determine if this course is right for you. Are you at the right place? So the first group of people this course is for are SQL Server DBAs. If you're a SQL Server DBA at any level, whether that is a junior level DBA to a senior level DBA, then this course is for you. Now, I would like to mention this is not an entry-level course. This is an entry-level course if you're a DBA or if you're a developer or a programmer. This is not an entry-level course if you have no idea what SQL Server is. So I've got lots of courses out there that are specific to understanding the basics of SQL Server. So go ahead and take one of those and then come back to this one when you feel comfortable with the basics of SQL Server. The next group are developers. If you're a developer and you want to get more out of understanding how SQL Server processes transactions and, more specifically, how it uses weight stats, then this course is for you. All right, so let's talk about the important points of this brief little lecture, right? This is not an entry-level course. It's only an entry-level course if you have a little bit of experience with SQL Server. So the two groups that I'm targeting are DBAs at any level, right? As long as you have some experience with SQL Server, this course is for you. And developers. And you don't have to be a SQL Server developer. You can be any developer. As long as you have a foundation understanding SQL Server, this course is for you. If you're in one of those groups, let's get started. How many times have you walked up to a SQL Server that has performance problems and said, where do I start looking? One of the most underutilized performance troubleshooting methodologies in the SQL Server world is called weights and queues, also known in SQL Server as simply weight statistics. The basic premise is that SQL is permanently tracking why execution threads have to wait. You can ask SQL Server for this information, and then use the results to narrow down where to start digging in to unearth the cause of the performance problems. The weights are what SQL Server tracks. The queues are the resources that the threads are waiting on. SQL Server has mechanisms to monitor query execution, and it logs not just the total time needed for the query to complete the execution, but also how long and what the query is waiting on in each step in the execution process. Having such granular data about each query execution helps to identify, more precisely, where the actual bottlenecks occur during the query execution process. Based on this, it's evident that SQL Server has the ability to monitor weight statistics from a query execution. What the query waits for and how long at each step of the execution it waits is both a powerful and a precise tool for determining the root cause of slow executions on SQL Server. Hello and welcome back. Now before we get started, we have to install SQL Server Management Studio. It's a separate install from this SQL Server engine. Why Microsoft decided to do that, to have two separate installs for the IDE and one for the engine, no clue. Either way, so we're going to come here and say install SQL Management Studio, and it should take us to the latest one. We'll try this one. Yes. SMS 18.6, we're going to download Management Studio, and we just click on there. You can see down here I already have it installed and pinned to the taskbar, but I wanted to show you how to download it and install it. Come on, why aren't you downloading? I clicked on you. There we go. Once it's downloaded, you go ahead and open File, and here is where we install SQL Server Management Studio. You can see my options are repair and uninstall or close. You're going to have an install. Because mine is already installed, it gives me this option. So we're going to close, And then you want to search for, navigate down to the start and type in SSMS. And you'll want to right click on this and then pin to the taskbar. Mine says unpinned because it's already pinned. And we'll just open up Management Studio from there. Once you have Management Studio installed, move on to the next lesson where we install the SQL Server engine with Python. All right, let's talk about the SQL weight statistics DMVs. The SQL exposes weight statistics primarily through two dedicated DMVs. The sys.dmos waiting tasks DMV is the view into the waiter list. In it, the SQL records weight statistics, i.e. the wait types and the wait times, for any request associated with a currently suspended thread, i.e. a thread that's on the waiter list, waiting for a resource to become available. Therefore, you can use this DMV to investigate the primary resource wait types for a server currently experiencing performance issues. Wait times and types for currently blocked requests also appear in the sys.dmexec requests. One common wait type that will show up in the sys.dmos waiting tasks is lock-related waits, where, for example, one long-running query blocks many other requests for a significant period. The second DMV is the sys.dms os wait stats. This DMV provides the historical perspective of most of the significant waits associated with the overall workload of the server. To give just one example, every time a thread for a request has to wait while SQL Server reads a data page into the buffer cache, the SQL adds the recorded wait time to the total cumulative time for the wait type, called page IO latch sh. In this DMV, the SQL records the wait type and the cumulative total time for each wait type. The term cumulative total time needs a little more elaboration here. So cumulative means for waits of each type, the DMV stores the cumulative wait times across all threads and all sessions since the last instance restart. That's really key right there. These are only held since the last instance restart, or since the last time someone cleared out the wait statistics manually. The second part of this is total. This is the recorded wait times, included in both the time spent by a thread in the waiters list, the resource wait, and the time it spends on the runnable queue, which is a signal wait. This DMV, the sys.dmos wait stats DMV, stores both the cumulative total wait in milliseconds, the wait time in milliseconds, as well as the cumulative signal wait, i.e. the time spent on the runnable queue, the signal wait time in milliseconds. All right, so let's go ahead and take a look at these two. So here's the first one, the DMOS waiting tasks. So if we execute that, again, I'll be including this in the lecture, so you don't have to type this out. You just copy it and paste it and run it. All right, so here's the second one in this next window, and this is the sys.dmos wait statistics. So if we execute that, these are the waiter types, right? These are the actual things that we're going to see that we're going to have to know how to interpret. Now, you might look at this and say, well, wait a minute. It seems to be a long list of wait types. As a matter of fact, a very long list of 1,069 of them. Now, the good news is you're only going to see 5 or 10, and these 5 or 10 will keep reoccurring wherever you go. And we're going to delve into that later. All right, so before we get started, we're going to need a database at some point to play with. So let's go ahead. I wonder if I have a database on my other 2017 instance. Let's check. Oh, I do. I have Test, Udemy, and AdventureWorks 2014. This is the one that Microsoft provides. So let's go ahead and back this up and then restore it to this 2019 instance. And when we do that, it'll actually upgrade that database to 2019. And let's work through how to do that. Let's right click. Let's go to all tasks. Let's go to, where is backup database? Right there it is, backup database. See, yeah, I mean, that's a fun location for it. Go to media options. We want to overwrite existing backup sets. Do we need any of this? Nope. How about backup options? Nope. Let's go to general. Let's script it out so we can see what's going on. All right, go ahead. Let's execute that. Can't find that path because it doesn't exist. All right, well, that's a problem, isn't it? Let's go back to our location. Let's go ahead and remove. Let's add. Let's go ahead and find a new location. F is, or what is it, D or F? F. is my, how about we go to put it in books, adv.bak. It's actually my SSD. Come on. Okay. All right, let's go ahead and script this one. Let's try this again. We're 0 for 1. All right, much better. Why is it taking so long? I enlarged one of the tables, so it's actually shouldn't take this long. I will include this database for you to work with. All right, so there we go. All right, now let's restore it to our 2019 instance, which will upgrade it. And you'll see that when we restore it. So let's click anywhere. Let's go here. Actually, let's go in databases. Let's go to restore database. Let's go find that database. It's a device. Where's that device at? It's on books. Let's see. No, why do I keep doing that? Books, adv.back. Okay. Let's go ahead and check out the files. Where do we want it? I guess that's fine. We could relocate to another folder if we wanted to. I don't see a reason why we would want to put it there. How about options? We want to overwrite. We want to place. Overwrite the existing database with the place. Yes, we do. Let's go ahead and script it. All right, let's go ahead and restore it to, are we on 2019? We are. All right, access denied, not location. All right, so we're 0 and 2 for the restore too, because there's an access denied for whatever reason, and that basically means we have to go and to the location and then right click and do a whole bunch of junk. We're not going to do that. So what we're going to do is we're going to right click and we're going to try this again, or we're just going to come to the restore database. We're going to go to general, and we're going to navigate to files, and we're going to put this in a different location. So let's put this in instead of 15. Let's go ahead and put this in a location where we know we have access to. How about books, which absolutely makes no sense, but we know we have access to it and it's not going to give us that error. Books, yep, that's great. So let's try this again. Looking good so far. All right, so this is what you'll see most of the time, all right? We've done the restore. However, this is the upgrade part. You can see we're converting database, this AdventureWorks, from this version to the latest version. And you can see it's running the upgrade steps. And it looks like we're successful. That's good news. So if we come up here and refresh, we now have the upgraded AdventureWorks 2014 database, which we can rename because it's no longer 2014 compatible, is it? Now it's really still a 2014 database in terms of its contents, but for us, ooh, what doesn't I like? Yes, I do. We're going to call it AdventureWorks 2019 because it has been upgraded and is compatible with our 2019 instance. All right, good to go. All right, hello and welcome back. Now we have a few things to install, and one of those things is SP Who Is Active, one of the greatest tools for a DBA known to mankind. Thank you, Adam Mechanic. You can see I've done this a few times. SP Who Is Active download. So let's go ahead and hit that. and our very first hit. Click on that. Here's the newest one, SP Who is active on GitHub. You can find the newest release there. Fine. Source code zip. Yep. There's Adam. All right, so let's open up the file. Click on it. Let's open up Management Studio and connect to our 2019 instance. All right, there's our 2019 instance. We're simply going to click on the master database, new query. Actually, we don't have to do that. I think if we just click on the SQL file, it should open up for us. Look at that. All right, so we open it up, we run it. That's all we do. And then the stored procedure is just who is active. So if we highlight that and run it, this is what we'll see. Now, I'm going to show you a watered down version of this that I use every day. Just a handful of columns. And we'll talk about that in a minute. But that's it. We've downloaded and installed SP Who is active. All right, hello and welcome back. Now, we have a few things to install, and one of those things is SP Who is active. One of the greatest tools for a DBA known to mankind. Thank you, Adam Mechanic. You can see I've done this a few times. SP Who is active download. So let's go ahead and hit that. And our very first hit. Click on that. Here's the newest one, SP Who is active on GitHub. You can find the newest release there. Fine. Source code zip. Yep. There's Adam. All right, so let's open up the file. Click on it. Let's open up Management Studio and connect to our 2019 instance. All right, there's our 2019 instance. We're simply going to click on the master database, new query. Actually, we don't have to do that. I think if we just click on the SQL file, it should open up for us. Look at that. All right, so we open it up, we run it. That's all we do. And then the stored procedure is just who is active. So if we highlight that and run it, this is what we'll see. Now, I'm going to show you a watered down version of this that I use every day. Just a handful of columns. And we'll talk about that in a minute. But that's it. We've downloaded and installed SP Who is active. All right, we have one more thing to install before we get neck deep in weight statistics, and that is something called SQL Query Stress. And you can see down here I have SQL Query Stress. I've put an icon on the taskbar. The only place I found that has it that's stable is on the Microsoft App Store. So come to the Microsoft App Store, and where's our search button? And type in SQL Query. See if we find it. Stress. It's not going to find it. That's all right. It'll find it when we hit enter. And you can see it's free here for download. And you just click on it and download it. All right. So what does it do? Well, it creates load for us. It allows us to generate load on an instance. It's a great training tool. So how do we do it? Well, we just connect to our database. So what's our server name? I don't know. Let's go back and get it. Right click, properties. Certainly not going to remember that. There we go. We're going to connect. Integrated security is fine. The default database is going to be AdventureWorks. All right. So let's go ahead and test the connection. So our connection succeeded. We say OK. And now we're ready to type in anything we want here. So let's go over to our AdventureWorks database. Let's move this over a little bit. Let's look at a table. What is a table? Let's come here. Right click on AdventureWorks. We're going to type a new query. And we're going to say select all from what? How about, I don't know. How about department? How many rows are here? Great. We're going to grab this. We're going to come over to query stress. We're going to drop that in there. Let's open up who is active so you can see this. So how many iterations? We're going to add quite a few. How many threads? Well, let's go with 3 threads. All right, now we need something to view the transactions as they flow through the database engine. All right, so we need SP who is active. And I think if I right click and new query, and let's say file, open, file, where's my open? Open, file. I think I saved Mike's SP who is active. Where did I save it? And I saved it under my external drive. Wait stats code. Who is active Mike? That's my version, my selected columns. If we execute this now, there shouldn't be anything because there's no load, because there's nothing running against our server. However, now that we have query stress queued up and we hit go, we move back here and we click on SP who is active, and something went wrong. Very strange. And we click on SP who is active. Why is it not showing us anything? Total exceptions? There are no exceptions. Cancel. Why are you not showing me anything? I don't know. So we connected the database. Everything looked great there. Authentication, it tested successfully. Great. No problem there. All right, maybe the execution of that is just too quick. So let's go and choose, because it's such a small table and we simply can't catch it. All right, well, let's go with a bigger table then. Let's try to catch a bigger table. What's a bigger table? I think error log's got some rows in it. How many? Nope, error log doesn't have any rows in it. That won't be a good one, will it? How about employees? No. How about how about sales? Sales order header. How many does this have in it? Now we're talking. Let's drop this in here. We're going to hit delete. We're going to hit Control V to paste it. And now, 5,000 iterations, 3 threads. Yeah, that's great. Let's go ahead and hit OK. Now we should be able to catch something in an SP who is active. And here we go. There we go. Now we're able to catch something. All right, why? Because these are taking some time to return. All right, so that is how we generate load. I'm sorry, that's the long way around on how we generate load for our learning purposes on SQL Server. I'm not sure if you can hear, but my CPU is all right, so go, it's finished. Is not happy. All right. So download SQL Query Stress, and we're going to get started learning about weight info. All right, in this lesson, let's talk about the top 5 waiters. These are the waiters you're going to see most often. Now, you don't have to memorize these. You don't even have to study these. I'm going to show you where to get these later, this information, but it's going to give you a good high-level overview of the big 5. The first one is called CX packet. The simplest explanation of this weight type is that there are parallel plans running. Much has been written about this type and what to do with it, and unfortunately there's a lot of bad advice out there. It occurs with parallel plans when trying to synchronize the query processor exchange iterator. If the weighting is excessive and cannot be reduced by tuning the query, such as editing an index, consider adjusting the cost of threshold for parallelism, or lowering the degree of parallelism. Be careful with parallelism. You want parallelism. The knee-jerk reaction here is to try to eliminate CX packets. This is incorrect, and it may be perfectly normal for your workload. You're going to need to investigate where they're occurring and determine whether parallelism is valid or not for this specific case. And if it's valid, is it working normally, or whether there is skewed parallelism happening. Now note in 2016 SP2, 2017, and in Azure databases, the CX packet weight has been split into a benign, non-actionable parallelism weights known as CX consumer weights. This means you should have fewer CX packet weights, and those that do remain are more likely to be indicative of performance problems. Next up is the page I/O latch. This wait happens when a thread is waiting for the thread of a data file page from the disk to complete, and the thread is going to be read, not modified, the page structure once it's in memory. Now, the knee-jerk reaction to this wait type is there must be some kind of problem with the I/O subsystem. It is true that long waits for I/Os are indicative of I/O subsystem when it's overloaded, but it's more likely a problem with SQL Server than with the I/O subsystem. You might need to think why SQL Server is doing so many reads. Now, with all that being said about page I/O latch, I'd like to mention that it's been my experience that lots of page I/O latches are almost always indicative of subsystem problems. The next one is async network I/O. This occurs on network writes when the task is blocked behind the network. You can go ahead and verify that the client is processing data from the server. This wait type is never indicative of a problem with SQL Server, and the majority of the time, it has nothing to do with the network either. A simple test for network issues is to test the ping time between the SQL Server and the client application or web server. And if the ping time is close to the average wait time, then the wait is because of the network. Next up is write log. This wait type happens when a thread is waiting for a log block to be written to disk by an asynchronous I/O. This occurs while waiting for log flushes to complete. Common operations that cause log flushes are checkpoints and transaction commits. If this waiter is combined with page I/O latches, then it might be a sign that the disk subsystem can't really keep up. The last one is called broker receive wait for. This wait type is when a thread is issued a receive wait for on the service broker queue and is waiting for a message to enter the queue. This wait could be a very long time if no message is transmitted to the service broker conversation. I haven't seen this wait type be a noticeable contention point. This wait type is one you often filter out as benign when you're doing wait statistics analysis, as the thread will wait until a new message enters the queue, which may be for a very long time. All right, so we're ready to dig into wait statistics. So we walk up to find how long our server's been up. Why? Because wait statistics gather since the last time it was restarted. Or, let's move over here, or until we run this code. Now, I'm going to include this code so you have access to it, so you can clear the wait stats whenever you want. Here, we can tell, I'm going to also include this query, when the last time SQL Server was restarted. And as you can see, mine was yesterday. So mine hasn't been up for a while. Either way, there's not a whole lot of information because we just installed it yesterday also. However, you walk up to a SQL Server and you want to find out all the wait statistics on the box since the last reboot. So how do we do that? We need a query to do that. And we're going to use a very popular query from an individual called Paul Randall, who's probably the foremost authority on SQL Server in the world. We come up and we go open because I think it's just a control 0 and that'll do open instead of. So I'll control O to open that. And I think I called it total wait stats. I did. So let's run this to find out all the information about our wait statistics on this instance. Remember, instance is an installation of SQL Server since the last reboot. And again, there's not going to be a whole lot, right? We've got write log at number 1, which accounted for 86% of the waits on this box. Now, if this were a real-world box, it'd be a serious problem. The next is async network I/O at 10%. Now, remember when I said you don't have to memorize these. Why? Because Paul Randall and others at his company called SQL Skills have done this. So if you don't know what write log is, you simply come over here to SQL Skills, his site, and you click on it. And it's going to take you to, well, it should have taken me to, I'm not sure why I did that. Why'd you do that? I want to go. It should pop me right open to that. That's very strange. All right, so we'll just pop it right in there. Should just open it right up. And now it takes us to information about write log on his page, right? And this will tell you everything you need to know about write log. Keep in mind, this is a very high level course. This can get very down the rabbit hole quickly. We're going to keep it high level. Let's kill that. We don't need that. So we've got write log, and it's our top waiter at 86%, and we've got async network I/O at 10%. Actually, let's navigate over to my other instance to see if there's any waiters on that instance. So let's go and right click on that. Let's go ahead and change connection. Connection to, change connection to the 27 instance express. I don't think I've done anything on this, but let's see what it has. Ooh, it has a lot more information. Apparently I've done a few things. And look, write log is number 1 here. So maybe there's a problem with my disk subsystem, right? Maybe the SQL Server is having a hard time writing to disk, writing the logs to disk. And look at here's page IO latch. We'll get into that later. So the very first thing you do when you walk up to a SQL Server from a weight statistics perspective is to get an idea what SQL Server is waiting on since the last reboot. And this is a script you use to do that. Hello and welcome back. We've moved back to our 2019 instance. Here you can see these are the weight stats from the previous lesson. Now, often you're not going to want to gather weight stats from the last reboot. What if the last reboot was 7 years ago? That's not going to give you a whole lot of insight into what's happening right now on your server. So what you want to do is gather the weight stats over a specific period of time. Often you're going to do this between core hours. Maybe your core hours are between, let's say, 10 a.m. and noon. That's when the server is the busiest. So you'll want to go between 10 a.m. and noon to get a perspective on your waiters. Let's go ahead and clear this out because we don't want this here. We don't have to reboot the server for that. We can just clear the weight statistics. Let's go back here. Now there should be nothing. All right, can't divide by 0. That means there's nothing. Great, thank you. Let's come over here and use the script by, guess whom? Paul Randall. Right? He's the author of it. And this is going to capture weights over a period of time. So the time delay is here. So our time delay for this is going to be 1 minute. That should give us time to create some write logs. So let's go ahead and run this. By the way, that's the only parameter we have to alter, right? So just that 1 minute. Let's move over to our SQL query stress. Here we've got some inserts. So let's go ahead and how many iterations? Yeah, this is the same from previous. So let's just go ahead and do this. And what we're going to get, I hope, after we do this, during our capture, is a whole lot of write logs, right? Because we're slamming the log file with writes. In the background, you can see our information is being gathered. By the way, this is production safe. I've never had this cause any issues. Let's cancel out of this because our 1 minute is up. Let's go back and we can indeed see that write log is our top waiter at 99% because there's nothing else going on in the box, right? We've cleared out the weight stats and we've inserted heavily. Where was that? I think it was on the AdventureWorks log file, right? Didn't we run this against? Where is, let's move back. Where are you, SQL query? There we go. Where is the database? Right, so the database should be, all right, so it's going to be, right, running against the AdventureWorks database, right? Again, I'm going to include the script, and this is a script I recommend you use the most, right? Because you want to capture your waiters during a specific period of time, right? During the time you believe that the server is having the most issues. That's going to give you the most insight into what SQL Server is waiting on. Here, we just slammed a whole bunch of inserts, right, against the database. So we can see now that 99% of the weight type associated with what we were doing is write log. All right, so your next question may be, well, what's the fix? Well, if this were a live box and write log was 99% of the weighting on the instance, you'd be in a lot of trouble, right? Because there isn't really a whole lot to fix. Right? You have to reduce the amount of inserts onto that log file, or you need to move that log file to a much faster drive. So if the database and the log file are on the same drive, that's a no-no. You want to move the log file to a different drive. However, because this is so high, let's pretend it is 99%. You're going to need faster disks. There's probably not a whole lot you're going to be able to do in order to negate this high of a waiter without doing something drastic like buying a shelf of SSDs. Hello and welcome back. Now, because this is such an important waiter, let's see if we can't describe it visually. The write log wait type is one of those wait types that can be often seen frequently on SQL servers, and it can give DBAs quite a bit of a headache. The write log wait time represents the time that accumulates while waiting for the content of the transaction log cache to be flushed to the physical disk that stores that transaction log file. When SQL Server has to store data in the transaction log, it doesn't do it directly by writing data straight to the disk, where the transaction file is stored. Instead, all the data is serially written to the log cache, often referred to as the log buffer or the log block, which is an in-memory structure. SQL Server starts to register write log wait types at the moment when the log cache starts to be flushed to the transaction log file. It is strictly related to the log cache and the transaction log file communication. The moment data starts to be flushed to the transaction log file, the write log wait type is registered, and as time accumulates until the log cache completes flushing data from the memory to the transaction log file to the disk. While it's evident from this explanation that it's an I/O operation related to the physical drive, the most important parameter related to the write log is the wait type. Now, this is really important, and the most important thing of everything we just learned about write log. The faster the disk subsystem, the lower the data writing latency in the transaction log file. All right, let's take a look at capturing our write log via SP.who is active. Now, oftentimes you'll be using SP.who is active in order to gain insight into what's causing issues on the server. If you aren't using SP.who is active, start. This will allow us to see the waiter on the individual SPIDs. All right, let's go ahead and see if we can't capture the write logs on the individual SPIDs. Let's move over to SQL Query Stress. Let's fire that off. Let's see, do I have everything working? Yep. Total exceptions, none. Good. All right, let's see if we can capture a write log. All right. Nope. Wait info, no. Nope. Nope. What's going on? There's no way that's done. There we go. There we go. No wait info. Some blockers, though, don't we? It's blocking. Come on. That's it. By the way, this is called sitting on SP.who is active. And we simply click to see the transition. Ah, there we go. All right, let's stop our query stress so it doesn't completely blow up the CPUs on my little workstation. So here we go. We've got 5 active SPIDs, right? They're all doing inserts. And every one of those SPIDs has write logs on it. All right? So we've been able to capture write logs on the individual SPIDs. And this, now obviously you're not going to see like this, but you may see a combination of, say, write logs and something we're going to talk about in a few minutes called page I/O latches. If you have those two, that's pretty indicative of a disk subsystem issue. Using SP.who is active allows you to gain insight with this wait info column into what waiting is going on per transaction on the server. Hello and welcome back. Let's learn about the page I/O latch. One of the most common wait types seen on SQL servers, and definitely one that causes a lot of troubles, is the page I/O latch. Let's take a look at the Microsoft definition first. Occurs when the task is waiting for a latch for a buffer that is an I/O request. The latch request is in shared mode. Long waits may indicate disk subsystem problems. So when the data pages are requested from the buffer cache by one or multiple sessions, but those data pages are not available in that buffer cache, SQL Server has to allocate a buffer page for each one in the buffer, and it will create the page I/O latch share in that buffer. At the same time, while the page is moved from the physical disk to the buffer cache, which is a physical I/O operation, SQL Server is going to create a page I/O latch EX wait type. These page latches are actually lightweight locks that are not configurable, placed by SQL Server on internal processes as a way of managing access to the memory buffer. Page latches are placed every time that SQL Server has to physically read data from the memory buffer to the hard drive, or from the hard drive to the memory buffer, and the thread must wait until this is completed, causing a page I/O latch XX wait. So it's clear that the page I/O latch share is directly related to the I/O disk subsystem. Hello and welcome back. In this lesson, let's talk about page I/O latches. Comically, here it's bubbled up to number 1, but I wasn't able to do that when it was live, when it was hot. All right, so let's see if we can't catch it when it's hot, or when the transactions are flowing. We'll see what happens. Either way, page IO latches are often a sign that the disk subsystem is struggling. And here you can see at 65%, this one is struggling. Now again, this, take a look at this on AdventureWorks. I've put this on files, the data file. Unfortunately, I'm on the root of a thumb drive that's probably, it's got to be 15 years old, 10 to 15 years old. So it should be nice and slow. But yesterday when I was trying this, it was able to handle it. All right, we need to clear these weights out. All right, so let's go get our clear script. Let's go ahead and hit Control O. And let's go and where is our reset the weights? Let's go and reset the weights on to make sure I'm at the right place. I am. Let's just move this over. Move this over. Let's see. Should be nothing here. All right, so good. Now let's fire off. Let's move over to SQL Query Stress, and we're going to do some selects against this table we've been working with, and we're going to see what happens. Now we need to do a few. One's not going to do it. 50,000 might. Let's go with 50,000 on. How about 50,005? Let's go ahead, go. Let's go over here and jump over to who is active to see if we can catch. All right, nope. No wait info. No wait info. Come on, give me something. Async network IO, yes. Makes sense because it's waiting for all the others to process before it executes. Nope, I think we're going to get it. All right, let's jump over to the cumulative look. Latches, look, we're getting page latches. These are in memory. Write logs, well, that's a good sign. We're getting write logs. But it's funny, no page IO latches. I'm flabbergasted that a 15-year-old thumb drive, here it is, that a 15-year-old thumb drive would be able to handle, even though this is a contrived workload, that it's able to handle this is crazy. And so we get over here, probably asyncs, if we get anything. Wait info, nothing. Oh, all right. Let's see if we can get the page IO latch ups to jump. Come on, up past number 11. Scheduler yields. Might have a little bit, you can hear the processor, the CPU struggling. That's often, we'll talk about this. That's often a schedule, maybe a scheduler yield problem. And it's not. Page IO latch is simply not going to move up for us. Come on. Nope. All right, let's go ahead and pause SQL Query Stress. So my workstation doesn't catch on fire. All right. So we weren't able to catch it live because I can't find a disk slow enough, which is befuddling because I know I've done this before. So anytime where we see page IO latches in the wait info column on individual SPIDs or anywhere in the top, let's say 3 to 5, right? You're going to want to look at your disk subsystem. Now, another indicator is this write log, right? If this bubbled up a little higher, we might be able to say we have page IO latches, which is remember the data being grabbed out of the buffer pool. I mean, data being grabbed off of disk and put in the buffer pool to be retrieved by a query, right? And then we have write log, which is the transactions being written to the log file. So we would have two at the top that were specific to the disk subsystem. And when you see that, that's often a pretty solid indicator that you've got some subsystem problems. All right, so even though this course is about wait info, it's not the only tool that we have in our arsenal to check whether the subsystem is having problems. So let's say we believe that the disk subsystem is a problem. All right, so I'm going to include the script, and it's going to take a look at the average stalls, right? The different stalls. So we've got read stalls, we've got write stalls, and over here at the end, we have the average IO stalls in general. This number right here, where is it? The average read stalls. Now, that is slow. 146 would indicate that the disk subsystem can't keep up. The Microsoft advertised number is 20 milliseconds. Now, that's not a realistic number. I mean, there are companies that have that because they have their data files on SSDs. But 50, I think Ozar, if I recall, Brent Ozar said 50 is probably a good number, and I agree with him. 50 and above, I'd start to get worried. Anything into the 80 and over range, this is problematic, right? So even though we've got weight stats, right, to look for information about problems, we also can use other tools to reinforce our deductions that one specific point is having a problem. All right, let's talk about the worst named waiter, async network I/O. It's funny, you can see here, now we're going to go into it, but you can see this from, I was doing some testing, and you can see we've got it to 70% or 69% of the total wait type. However, if you look at this, you would say async network I/O. So I'm sure it has something to do with the network. Well, this is a laptop. I'm not on a network. There's no network anywhere. So I am not sure what network they're talking about. This is probably the worst named waiter in the catalog. Number one, it happens often. And number two, it's no cause for concern. This is one you can probably safely ignore. All right, so what is it? It occurs when the SQL Server is just waiting for other data to be processed by the transaction. That seems a little obtuse, so let me show you. So let's come over here and clear this out. Clear, clear. I want it all gone. Are you gone? Yep, that's good news. All right, so let's go click on query stress. I'm going to need to set the database up again. Properties. Yes, give me this. Come on, give it to me. Come on, stop. Why must you be so difficult? Our database, okay. Now we want to select. Let's see, do I have it open anywhere? Nope. So let's go look at the tables. I want a simple select. So query. So it should be select all. From it's called T1. Yeah. How about that one? How about I get a 1? All right, so you can see it's executing the query. Great. Copy. Stop. Let's go and drop that into stress. Query stress. Now let's fire this off with quite a few transactions. And we should see async network I/O bubble. No, that's too many. Bubble to the top. Let's go ahead and go. Now, we won't be able to catch this with who is active. We can try. Let's go. Maybe we will. No, that's not the one I want. Did I close who is active? Come on, mouse. I think I closed it. Here it is. Can I get an async? Oh, look at that. I got one. I have more than one. You can see we have quite a few of async network I/O. And you can see we have one on every thread. And what's interesting is there's no network. All right. So we know this isn't associated with network I/O, right? Even though this would lead you. All right. All right. Please don't kill my machine. Even though that's what it looks like. All right. It's simply waiting for these selects to be consumed so another one can be kicked off. And if we come over here and we look, we can see that our top waiter is async network I/O with 65% of the wait time for that selection. All right, so if you see this, at least you know what it is. Ignore it. All right. All right, welcome back. Let's talk about a type of contention we can often see in TempDB using wait statistics. All right, so the first thing we want to do is run this script. Let's go ahead and execute it. It'll say it's already there. Great. We want to put this in TempDB. I'm going to put it in the SQL Express database. Now, you don't have to do that. Let me show you. It'll just be easier for me to show you with two separate instances. Well, let me show you why, too. So this instance has one TempDB data file. So we come to files, we can see it has one tempdb data file, right? In 2019, Microsoft has corrected that. Now, when you install SQL Server, you get multiple tempdb data files, right? And that is to alleviate this specific contention we're going to talk about right now. Cancel. All right, so we want this in both tempdb databases. It is. I've added it. Let's go ahead and kill this. Let's go ahead and, well, we don't have to clean our stats because we're not going to look at the cumulative. We're going to look at SP who is active and see the weights here. It'll become glaringly obvious. So we have SP who is active. Where are we? We are on 2019. All right, let's show the contention first on the one with one tempdb on SQL Express. All right, so let's go right click, connection. Let's go ahead and change our connection to SQL Express. Go ahead. Yep. Let's grab that too. Connect. All right, so we're at SQL Express edition. Now let's come over here to query stress. We're going to execute tempdb stress, the name of the stored procedure, against that instance. So it should be tempdb SQL Express. What database? AdventureWorks 2014. No, we're going against tempdb because that is where the proc is. Test connection. Okay. Okay. Let's go ahead and 500 to 10 should do it. Let's go ahead and fire it off. And right away, we should be able to see some tempdb contention. And it didn't take long, did it? There it is, the weight info. Page latch ups on GAM. Let's see if we can see a few more. Yep. There's some locks. There's no weight info there. And here we go again. More. Let's stop. Okay. We get it. We've seen it. Oh, it did stop it. We've got page latch up tempdb on these PFS files. All right. So what does PFS mean? PFS means page free space. So what's going on is tempdb is hitting the hotspot on one of those special pages, just recording how much space is available and where. There could also be some GAM weights. GAM means global allocation map. That's another one of those special pages that can get hot and slow things down in tempdb. It's tracking where the objects are allocated. There's also an SGAM, which is called Shared Global Allocation Map pages. You might see those also. These type of waiters can be eliminated, especially on tempdb, by adding more tempdb data files, not log files, because you're going to get more PFS pages and then GAM and SGAM pages across the files. So now, in order to remedy this on Express, we would come here, right-click, Properties, Files, and we would add more tempdb data files, right? It would look like this. All right, well, let's go ahead and do that. Let's add one. Right-click, Properties, add temp dev 2, because there's temp dev 1. This would obviously be temp dev 2. Let's go ahead. You want to set them all equal. So let's go ahead and set these to 500 each. We need to set you to 500. Let's come over here. Notice they are on my C drive, which is never a good idea. Not only that, my C drive is really slow. And we'll call this tempdb.ndf. It's a secondary log file, right? Let's go ahead and script this. Let's go ahead and edit. And if we come over here to tempdb, let's go to refresh our databases here. Refresh. tempdb, properties. Oh, look at there. Now we have another row. Now you need 4 of these. You want these in 4s. So you would add 2 more here, right? And then if that didn't do it, you'd add 4 more for a total of 8. And if that didn't do it, I think you get the idea. Let's cancel over here. All right, let's bring this back. All right, now that SQL query stress has stopped blowing up my box, let's go over here to XQ. What is it? There's proc in there. Now let's go ahead and fire this off against the instance with more temp. How many temp DBs is this? Didn't have 8. I think it had 8, right? Yep, with 8 temp DB files. All right. Open up database. All right. Cancel that thing first. Let's come over here and change our connection to that one. Copy, connect. Now we're on 2019 instance. Let's come back to stress. Let's go ahead, database. Let's go ahead, Control V. All right, so we want to go to tempdb. Test. Now, when we do this, let's see how many threads. It's still 505. We're still probably going to see contention. Why? Does that mean we have to create more tempdb files? Maybe, but it also means we should look at where those tempdb files are located, right? I just showed you those are on my C drive. The C drive on this machine is a spinny disk. It is not SSDs, so it's going to be slower. So both of these files on both of these instances are on slow spinny disks, all right? You want to put tempdb data files on SSDs all the time. Let's go ahead and see. We're probably going to get, oh no, look at the weight info. There's nothing in the weight info. It's able to handle it. All right, there we go. It is able to handle. We're not seeing any GAM. All right, let's stop this. Stop, cancel, great. This is just burning up my CPU. I don't know if you can hear it. So we're not seeing any weight info because it is able to handle the load with the additional tempdb data files. All right. And it's nice that we can easily see on the individual SPIDs the PFS, GAM, and SGAM contention. All right, so this next one called preemptive OS write file was a little harder for me to get the bubble up to the top. Let me show you what I did. The first thing I did was, let's go over here to our database, AdventureWorks. I want to slow it down because in most of these lessons I've had the data file and the log file on an SSD, which means it's really fast. However, for this, I moved the data file to a really slow drive that I had for 10 years or so. And you can see I put it on the root of E, which is never a good thing, but it doesn't matter. It's just basically an older thumb drive. And we're going to see if we can't overload it. So let's go ahead and cancel that. And here you can see this. Again, I'm not sure I'm going to get the bubble up, but it's a preemptive OS write file, and it's an easy fix. Let me show you. Let's see if we can get it to bubble up. All right, so the first thing we need to do, let's go ahead and clear our weight stats. Let's move this over here for a second. Don't I have that open? Yes. Let's clear the weights. You know, I don't have my insert statement inside SQL query stress, so we're going to have to go find that. So Control O to get that. Here's my inserts. Yep, this is what I want to see. Thanks. Let's grab that. Nope. Let's put that in query stress. Does my database set up? Yep. Test. We're in good shape. All right, let's go ahead and, oh, there is one more thing I want to show you. So in the weight statistics script, this is the, what do we call this one? Total weight stats. All right, this is the Paul Randall script that looks at the sum of all the weight stats since the last reboot. All right, so here, simply add 2 dashes. And what's 2 dashes mean? It makes it a comment. So that's now a comment that's going to be ignored. right? Because we don't want this code in here right now. Actually, this was the original code, I think, is 95. But we want to see everything. All right, so let's go ahead and execute. Look at all that stuff. I said clear it. What's going on behind the scenes? Reset it. Reset it. Clean. All right. Let's go and fire off this. Now, again, I don't think I'm going to be able to see it via the, where's who is active? I think all we're going to see is write logs once this thing gets spun up. Okay, I'm just going to figure something out. Yeah, we're going to need more than that, aren't we? We're going to need a little bit of a load. So let's go ahead and add a little bit of a load. Now let's go. There we go. Let's see what we catch. Probably just write logs, I'm guessing. There we go. Write logs. Yep. Write logs. All right, because write log is it's going to be the top waiter here. All right, so we're not going to be able to catch it here via who is active. All right, so let's come over here and catch it via this statement. So let's run the statement. Again, write log, obviously. All right, that's the top one. We've got some page IO latch, which we're going to talk about in a minute. The latch, page IO latch, means it's going to have to go to disk. And why is it going to have to go to disk? Well, because it's on a slower drive, right? Remember that the final resting place for all your pages, for all your data, is going to be the disk subsystem. So if it's not in the buffer cache, if your pages that SQL Server needs, it has to go to the disk subsystem. That's why we're seeing page IO latches here. These two are what I wanted to show you. All right, so we've got preemptive OS, write file gather, and write files. All right, and this is an easy fix. So if we come over here, let's right click on this. We'll go to properties, and oftentimes the defaults for the growth of the database, all right, are incorrect. Now here, I toggled this down to 1 megabyte. All right, obviously that's not the default. What is the default? Let's find out. Right click, new database. And how about Udemy? Yeah, sure. So it looks like as we create that, the initial size is 8. The auto growth here in megabytes, 64. No, I guess that's not so bad. I mean, it's going to be a small database. I think that's better than it used to be. All right, so what's happening is that the database is growing in micro increments, and we don't want that. That kind of floods the SAN or the disk subsystem. We want larger growths, and the growth is going to depend on how much activity. For this, we certainly want it to be more than 1 megabyte. So for our example in this little database, 100. All right, so here we wanted to grow in megabytes. Let's go here and let's go with 100. Okay, that's what we want. All right, so let's go fix that. And I have another way to show you the growth in increments. I will include this script. Let's call this, what do you want to call this file? Save as, let's put it on, where was it? It was here. I think it was called wait stats code, and we'll call this data. Data. How about check? Or how about growth increments? All right. Yeah, doesn't matter. All right, so let's go ahead and execute this, and you'll see what I'm talking about. So here we go. You see this? So the AdventureWorks database, here is the change in size. So what happens is every time we're doing inserts, the data file has to grow, right? So what's happening is because this is so small, it has to grow every 1 megabyte, right? And that's basically causing lots of writes to the SAN. We don't want that, all right? See this? These are the duration in milliseconds of the change. We want this gone, right? So for our purposes, our 100 will do away with this. All right. So these preemptive, these write files, they're often associated with incorrect sizing growth on the database. Now, it's going to be a lot easier to see it in SPO as active, right? Because you can see on the individual, I don't think I have, no, there's nothing here. You'll be able to see, right, this on the individual thread. So you'll know if you see the file growth here, you'll know, you come over here and say, oh, I see it's on the AdventureWorks database. And unfortunately, because the write log is so prevalent here, I can't get it to bubble to the top. However, if you do see that, these preemptive file growth, you'll know that you want to check the size of the data files of your databases. And again, if they don't bubble up here and all you get is here, let's say this is top 10, then you have to go through all of them. And so, all right, in this lesson, let's talk about SOS scheduler yields. This can be a problem with the CPUs or the processors, but not always. Let's go ahead and push this to the top. We can do this pretty easily by going to Properties on our server. We're going to go to Advanced, and we're going to hit this setting called Max Stop. And what we're going to do is limit any query's ability to parallelize to 1. That it's a no-no in production settings. Right? I would not do this. You want parallelism, and basically this turns it off. So let's go ahead and turn it off. And let's go ahead and move over to our favorite tool, Query Stress. And let's go ahead and do everything set up. Let's go ahead and execute this and see. Well, you know what we want to do also? Let's go ahead and clear our wait stats. Clear. Okay. Now, if we run the wait stats, we should have nothing but, there it is, async network IO and SOS scheduler yields. Okay. Let's see if we can catch the scheduler yield here. Probably not. Probably a whole bunch of asyncs, but maybe. Nope. Wait info. Nope. Come on. Come on, wait info column. Give me something. Where are we at over here? All right, here we are. We are number 2, and you can see 36%. And you can hear, as you could most of the time throughout this course, the CPUs on my workstation are just burning up. Now they're really burning up. They're really upset. All right, let's stop this. Okay, so we're not going to catch it in who is active. All right, but we are going to catch it in our cumulative. So let's run it again to make sure we are it again. There we go. 31%. You can see we're struggling. Now, let's stop. Query stress, please. All right, let's make sure it runs its course. Execute. All right, there we go. We're done. SOS schedulers can be the result, obviously you just saw, of pressure on the CPUs. However, it can be bad code. Especially if it happens all of a sudden. I was working at a client like probably about a month ago, and I was sitting on SP who was active in, I was looking at the script, and all of a sudden their CPU went from 1 week, we're using a tool to monitor it, I think it was SQL Monitor, and it jumped from, averaging 60% to 90% in 1 week. All right, so like on a Monday. So we knew that something was a little off. That kind of jump isn't probably has nothing to do with the pressure on the CPU. That has to do with code. And sure enough, when we finally got down to it and to the bottom of it, 2 developers had implemented some code. They had pushed it to prod. They hadn't told anyone, and it caused significant load on the box. We're going to look at the cumulative scheduler yields. We're at 31%. So if we change this, we're going to change max stop to be able to use eight. We use 8 processors. We're going to knock that down to 5. We're going to say, okay, let's see if that drops down our scheduler yields. All right, so let's go ahead and clear it. Clear, yep, clear. What do we have? Good. And let's go ahead and kick off Query Stress again. All right, so the longer this runs, I shut down Query Stress because it was blowing my machine up. So the longer this runs, we can see our scheduler yields are dropping significantly, right? And that is because of the altered max stop setting. All right, so we have 2 takeaways here. If you see high SOS scheduler yields, It may mean that there's pressure on the CPU, but it also may mean there's pressure from some bad code. All right, let's talk about some free resources where you can go and get some more information, some more detailed deep dives on the subject. The first is going to be the SQL Server Wait Types library from SQL Skills. This is Paul Randall and Kimberly Tripp's site. Paul and Kimberly are certainly two of the foremost authorities on SQL Server in the world. So here, we just go to SQL Skills, Help Waits, and we just say, what about Async Network I/O? We click on it, and it gives you information about this waiter, right? Another site I like is this guy's site. His name is Nicola. I can't pronounce that. Sorry, Nicola. And he does a very good job of going into these deep dives where he uses some picks, and picks really help you represent a problem. So here he's talking about Async Network I/O. And lastly, if you're having problems with a waiter, you can just Google it and see what information outside of these two free resources you get. All right, let's take a few minutes to review what we've covered in the course. You learned about the write log waiter. This wait type is when a thread is waiting for a log block to be written to disk by an asynchronous I/O. It's extremely common to see write logs as one of the top waiters on servers, but there's still plenty of things you can do about them to alleviate them. Here are a few things you can do to eliminate them. Number one, you can reduce the amount of transaction log being generated. That's often easier said than done. You can reduce how often log flushes occur. And lastly, my favorite, you put the transaction log on some faster disks. Anytime you're responsible for architecting a SQL Server solution in the real world, you want the fastest disks you can afford. You learned about the page I/O latch wait type. This occurs when a task is waiting on the latch for a buffer. It's an I/O request. Long waits of this one indicate problems with the disk subsystem. In the real world, you'll rarely be able to tune your way out of these latches. These often indicate that the disk simply can't keep up. You know what I'm going to say next? Add some faster drives. You learned about the Async Network I/O waiter. This waiter has nothing to do with the network. This wait type is where SQL Server has sent some data to a client through TDS, and it's waiting for the client to acknowledge that it's been consumed. This wait type is never indicative of a problem with SQL Server, and the majority of the time it has nothing to do with the network either. This waiter can safely be ignored. You learned how to handle TempDB contention when those nasty PFS scam and SCAMs showed up. If adding TempDB data files doesn't work, then move those TempDB files to faster drives. You learned about the preemptive OS file ops wait type. This wait type is a generic wait type for calling a thread and one of the several Windows functions related to the file system. If you see this one during core production hours, take a look at the file growth on your database data files and adjust them accordingly. You learned about the SOS scheduler yield wait type. This occurs when a task voluntarily yields the scheduler for other tasks to execute. If this waiter is a prevalent wait type, it may indicate CPU pressure is a problem, but it doesn't necessarily mean that CPU is not powerful enough to process a user requests. I've seen a few less experienced administrators often set max stop to 1. You don't want that in order to troubleshoot excessive CX packet waits. This can result in high SOS scheduler yield wait types on the system, a direct consequence of inappropriate troubleshooting. Lastly, don't forget to look at these in concert with one another. For example, on your system, if your highest waiters are write log and page I/O latches, then that may be a good indicator that you definitely have a disk subsystem problem.